Okay, so we're gonna go over the homework, which is questions 1 through 12 on the homework. And I'm going to show you how I do this using Post-it notes. You can use any scrap piece of paper, doesn't have to be a Post-it note, to get rid of the wrong answers. Question 1 starts with the 2 extrusive glassy texture rocks that are non-vesicular. So the first thing I do is get rid of anything that is not extrusive. So when I do this, I cover up all of the intrusive rocks. So that leaves me with 10 possible choices. But again, we only wanted 2. So you have to go back and narrow it down some more. It said extrusive that are glassy. So remember, glassy is a type of texture. For extrusive, it could either be glassy or fine. So I only wanted the glassy ones. So I'm going to cover up all the choices that are not glassy. So that leaves me with 4 choices. The next part said we wanted extrusive glassy that are non-vesicular. So over off to the side here, this was our texture continued yesterday. There's 2 choices. There's non-vesicular and vesicular. And remember, vesicular means gas pockets. Or for those of you who are in lab, it's the one that has the holes in it. So anytime you see holes, that's going to be vesicular. So we wanted the non-vesicular. So I'm going to cover up the ones that are vesicular. And that leaves me the only 2 choices that are extrusive, glassy, non-vesicular are these 2, obsidian and basaltic glass. That one was already done for you. So then the first one you had to do on your own was extrusive. So again, extrusive. But this time I want, where are we? Glassy texture again. So I'm going to go back up here to these same 4 I had before. But this time I want question 2 asked for the vesicular. So those are these ones. I want to cover up the non-vesicular. So that leaves me with pumice and scoria. So by the way, as long as we're at it, this is not part of the homework. This is about to help you on lab. Let's say you had pumice and scoria in front of you. They're both extrusive, glassy, vesicular, pumice and scoria. How do we tell the difference between those 2? Those of you who are in lab today, I expect you to remember this. Pumice and scoria, what'd you say? The color. So remember, and this is where I rushed yesterday, especially with this period 8-9. I rushed with you yesterday about this. Color, density, and composition are listed down here. You could figure out the density, but I'm not expecting you to. You can't figure out the composition, but you can look at 2 rocks and tell me the color. And by color, I don't mean purple, green, or blue, or brown, or black, or white. I want to know, are they light in color? So any on this side are going to be light in color, and any on this side are going to be dark in color. So if you've narrowed them both down, you've got glassy, extrusive glassy with vesicular texture. Pumice is going to be light, scoria is going to be dark. So that's how you tell the difference. And it's, again, it doesn't matter, is it white or gray or brown? When you have the 2 of them, dark, light. And with that, you go with your gut. Like, for example, what would you guys call this one? Light or dark? Yeah, if you had to pick one, this is more light than it is dark. So this is also going to be on this side. All right, so that's that. So I just wanted, that was not on the homework, but I wanted to help you with your lab. That should help with lab. So we've only done question 1 here. So this, or 2. Those 2 were pumice and scoria. What is the grain size? Now here's another thing. Does your reference table say grain size? It does not. But could you add grain size where it says crystal size? They'll use those 2 words interchangeably. Grain size and crystal size. It just means the size of the pieces in it, whether what the crystals or the grains, it doesn't matter. So I just labeled that grain size so I didn't forget. And it wants to know the grain size of glassy. We took notes on this yesterday, but it's not something you have to memorize. Here's glassy. Right next to that is the crystal size column, and this says non-crystalline. So what do I write down for the crystal size of glassy? None. So it's almost like a trick question. There is no crystal size because there are none. I actually want to go over question 4 and question 9 at the same time here. They both ask, what is the cooling rate for an extrusive rock? And this one is that's glassy, and this one is with a fine texture. So let's talk about the cooling rate, which just means how fast do these rocks cool? How fast do glassy rocks cool? No, I want to know how fast, not how big. Fast. All extrusive cool fast. And we took those notes yesterday. We said they cooled quickly on the Earth's surface. But here's a kicker that I want to make sure you understand. Glassy and fine, yes, they both cool fast or rapidly. But which one's going to cool faster than the other? They're both extrusive. So they're still both extrusive, which cool fast. So of these two extrusive one, what's going to cool faster? Glassy, good. And how that happens, or how you should know that, is there is 0 time for crystals to form. They cool so fast that crystals can't even form, not even teeny tiny ones. So that's where that comes from. So what I want you to write for 4 is very fast. So add that very if you didn't have that in there. And then down here for 9, which asked about the ones with fine texture, you can just write that one as fast. So that you do remember that the very fast give you glassy and just fast gives you teeny tiny crystals. One more thing I kind of want to get slightly off top, actually it goes with this one. Where are extrusive rocks formed? Above the ground or on Earth's surface? Above ground is perfect. Did you just see me not be able to spell above? What were you going to say, Cynthia? Yes, there was. I probably meant to put where our glassy rocks formed and then where our fine formed, but I think I forgot. One thing I want to talk about, on the Earth's surface or above ground. So you guys can picture a volcano erupting and spewing its lava on the land, right? I want to point something out that you may not have thought about before. There are underwater volcanoes in the middle of the ocean. So there's these underwater volcanoes. Are they going to make extrusive or intrusive rocks? They will be extrusive. So even though they're underground or underwater, they're not inside the Earth. So do you see the difference there? They're still on the surface, they just happen to be underwater. In fact, those ones, when lava hits water, how fast do you think those cool? Very, very fast, yes, because that water is really cold compared to the hot lava. So those are definitely going to be extrusive. So I just wanted to talk about that in case you'd never thought about it, because I'm sure you never did think about it. All right, let's keep going. Extrusive fine rocks that are vesicular. So that's the same deal. I'm going to come back to my handy dandy Post-it notes. First, I start with extrusive. Then I get rid of anything that's not fine. So I want to cover up the glassy. So that leaves me with quite a few choices. What did this one ask for? Vesicular or non-vesicular? This one wanted vesicular. So over here, the bottom half is the vesicular or the non-vesicular, and just these little section right here for vesicular. So I cover these up. My three choices are vesicular rhyolite, vesicular andesite, and vesicular basalt. Because I messed up, Cynthia. Cynthia, I'm not perfect. I'm just better than most. Nothing? Nobody? All right. You must believe me. Rhyolite. So yes, I asked salt. I asked for 3 and gave you 4. Now, did you notice on the next one? Asked for 4 and only gave you 3 lines. Hopefully you still gave me 4 answers. Oh boy, did not. So now when you go here, I want fine, extrusive, fine, non-vesicular. So I already got, there's my fine hanging out by itself, but now I want to get rid of the vesicular. Which one did you not include? Because there should have been 4. I bet you left off diabase, didn't you? Yep, because diabase is that one that can be either fine or coarse. So the 4 choices are rhyolite, andesite, basalt, and diabase. What is the grain size for fine texture? So here's fine texture. Read right next to it, less than 1. We already covered the cooling rate. Those should be fast. And yes, where are they formed? Same as before, on Earth's surface. Another word for extrusive, you do not have to memorize it. There's the word extrusive. There's the word, what is it? Volcanic. And then finally, what does vesicular mean? Again, and not something you have to memorize. It means gas pockets. And just so you realize what a gas pocket is, I know we talked about this at the beginning of class, it's a hole in the rock. So anytime you get a rock and it's got holes in it, it's going to be vesicular. How'd you guys do? Not bad? You did wonderful? Good. You did? Perfect. All right, so that's that. Now you'll notice there's more questions on the same thing on 19 and 20 and 21 and 22 and 23 and 24 is going to be the end of igneous rocks. So that's a lot of practice. So we clearly have more practice to do on this, and we're going to bring that up next week. But because we're moving along in lab, I want to make sure you can read, just bare minimum, I want to make sure you understand the sedimentary rock chart. So if you could flip to page 25. So we'll come back to those rest of those pages. So don't cross them off. Don't rip them out. Leave them there. You raise your hand. Yeah. Yeah, I'm not even going to grade them until next week anyway. One thing I want to say is mine printed out blurry. How does yours look? A little bit blurry? Good. I don't know how you guys feel about your blurriness, but if it's hard to read this, we are on page 7 now of the reference table. So it's the same one. It just ended up a little blurry in the packet. So that's the packet, not you, if you were thinking it's blurry. You don't need to go get your eyes checked. So it's page 7 of your reference table. And we're going to be talking about sedimentary rocks. So just a quick reminder from this reference table, how do sedimentary rocks form? From sediment. So again, just a quick refresher, how do you read this reference table if I want to know how the rock forms? What do I got to do? Go backwards. So I start at sedimentary and I read it backwards. It comes from sediments that get deposited, buried, compacted, and cemented together into sedimentary rock. So we're going to be talking about that type of rocks today. And so again, they are right here. So just like the minerals, just like the igneous rocks, they start with getting broken up into groups. What groups are here? What do they sort them by? They're what? Crystalline, clastic, and bioclastic. So in other words, they look at their texture. And once again, texture does not mean smooth, soft, rough. That's not what I'm talking about. Here, they have a different meaning. And the words are clastic, crystalline, and bioclastic. Now, those should probably, crystalline does crystalline sound familiar? What do you think that's made out of? Crystals. So crystalline, I'm sure you can handle. But what the heck does plastic? And I'm not mispronouncing that. I'm not saying classic, and I'm not mispronouncing plastic. The word is clastic. It is. But clastic should be a brand new word for you. However, they do give you a hint. In parentheses underneath it, it says fragmental. So what are they made out of? Fragments. These are fragments. These are crystals. And let's put 2 and 2 together. What do you think? Bioclastic. What does bio mean in science? Living, like biology. Is that not what you said? That's what I thought you said, darn it. Biology, like the study, last year you guys actually were in biology class, living environment stuff. So these are living fragments. So fragments of things that used to be alive, like fossils could be there. Or as you notice, one of these is coal. So coal, we already talked about, is a fossil fuel. It's made out of things that were once alive. So what we need to know is we need to start taking some notes on this reference table. So the first thing they get separated by is their texture. You'll notice then this group is completely different than this group. If you get one of these 5 rocks, you know it's made out of pieces of other rock. For example, this one. How is that showing? Okay, it's showing up a little bit. You can see these giant hunks. And if you were actually looking at this one up close, you would see that this looks like, can anybody see what that looks like? Or is it too blurry? What do these pieces look like? Do they look like fish tank gravel to you, or is it just me? A little bit. That's basically what's in here. And I'll pass it around so you can actually see. You can see in this rock, there are like little pieces of stones that look like either fish tank gravel or the gravel, you know, those little teeny tiny gravel on playgrounds that always end up in your shoes. It looks like a bunch of those just stuck together in this, a bunch of different colored ones. So that is one of these. When you get a rock that's made up of broken pieces of other rocks, what makes them different from each other? Take a look at the reference table. What makes conglomerate, breccia, sandstone, siltstone, and shale different from each other? Their grain size. I want to show you something. Their composition, which is what they're made out of. What do you notice about the composition of those 5? They're all the same. They're all made out of quartz, feldspar, and clay minerals, may contain fragments of other rocks and minerals. They are legit made of the same ingredients. So how are they different? The only thing that's different about them is the size of their grains. However, if we come down here to the bottom half, is the same true down here? No, these ones all have basically the same size grain. What's different is just their composition. So next week, we're going to be starting this in lab. So let's go ahead and put our notes, just like we did yesterday. I have an actual reference table, and we are going to just copy down the important facts. So we're going to start with clastic. Sorry. Clastic, crystalline, and bioclastic. Can everybody see that, or do you need me to turn off lights? I cannot make this one bigger. Everybody good? Okay, copy those 3 vocab words down onto page 25. We already discussed grain size and composition, so I'll add those up there too. Grain size, again, is just how big the pieces or the crystals are. And composition is just what the rock is made out of. So we already started talking about the grain size and how grain size matters up here for the conglomerate, breccia, sandstone, and siltstone one. So that's important that you understand the grain size. Now, the grain size means the actual pieces that the rock is made out of. So in this one, I already talked about this one looking like it had little pieces of fish tank gravel or little stones from a playground. So it's basically a bunch of those that got stuck together in mud and it formed a rock. So you need to be able to identify that by the size of the grains. So let's talk about how big the pieces are. So for shale, do you guys know what shale is? Where do you find shale? The creeks. You guys ever skipped a stone? What kind of stone do you use to skip? Those nice flat ones. So is it this? No, you need those nice, they come out in nice thin layers. I have one. Here's not a perfect skipping stone, but pretty darn good. So those really thin, they come apart in layers. But anyway, shale is made out of clay. Now, a lot of you, especially those of you who take ceramics, you think of clay as that like gooey, sticky stuff, right? Which it is. But when I'm talking about it's made out of clay, I'm talking about the individual pieces of clay. And the clay is the dust. If you've ever been in Mr. Losey's room, his whole room is covered in a fine layer of dust. They cannot even clean it up. You wipe the tables and it looks like it's still got dust on it. If you play with clay at the creek, when you're done, you've got that fine layer of like muddy dust on your hands. That's what I'm talking about. A piece of clay is 0.0004 centimeters. So your pinky is about 1 centimeter wide. So you need to be able to divide that by about 10,000 pieces for one piece of clay. Can you cut your pinky into 10,000 pieces? Would you be able to seal? No. Clay is so tiny, it's practically microscopic. Same with silt. Silt goes from 0.0004 to 0.006. So still your pinky divided by 1,000 there. Still can't do it. Still very tiny. Sand though, you guys have been to the beach or been to a sandbox. Can you see one piece of sand? Not well, but can you? Yes. Sand, it almost looks like tiny pieces of like a grain of salt. So it's 0.2 centimeters. That's visible. 0.2 is from here to from my finger to the top. It's small. It's about 2 tips of a pen, but it's still pretty small. But you guys know what sand looks like. Let's talk about pebbles, cobbles, and boulders embedded in sand, silt, and clay. How big is a pebble? Show me. How big is a pebble? Now, I'm like actually asking. If I said, show me a pebble, how big of a rock would you pick? A pebble. Pebbles are small. Most of you did something like this. Most of you are right. But what you may not read, oh, so I got to show you exactly how big a pebble is. If you flip your reference table back over to page 6, you will see this reference table. We're going to become very familiar with this reference table in about a month. But for this week, I just want to talk about clay, silt, sand, pebbles, cobbles, and boulders. So you can see here these dotted lines, they mark off the beginning and end of each thing. So clay is anything less than that 0.0004. We already talked about that. We already talked about silt. We already talked about sand. But pebbles can be that small. That's pretty small. And then they can go to 6.4. So they can be about that big. So all of you who sets up about that big, that's good. That's about how big a pebble is. Or like even back to the fish tank gravel, that's a pebble. Have you heard of cobbles before? Anybody heard of cobbles? Have you ever heard of a cobblestone road? Those are roads made out of actual rocks. And those cobbles, they're about the size of a brick. They go from 6.4 to 25.6. So they're rocks anywhere in that size range. So that's about the size of like a normal brick. And they used to make those to make roads because they were easy to pick up, but not so small that you needed like millions of them to make a road. And then a boulder. Before today, if I asked you how big of a boulder or how big a boulder is, what would you show me? How big is a boulder? You'd all pick up a rock this big, right? That's a boulder. But a boulder is actually much smaller than you would have thought. A boulder is anything bigger than 25.6. So anything bigger than that. Notice it's about the size of my head. So about anything as big as your head or bigger is a boulder. So they actually tell you how big those pieces are right here. So I did want to show you that reference table. All right, the last two are super easy. Rock name, I don't even think I needed to include a bubble for that, but I did. It's the name of the rock. Notice I did not include a bubble for map symbol. For right now, I want you to pretend that that last column does not exist. I don't want you to cross it off. I don't want you to cut it out. I just want you to ignore it for now. We will use it several weeks from now, but right now we're ignoring it. One thing I want to make sure you understand, this is not what the rock looks like. There is no rock out there that has a bunch of tiny bricks in it. So this is not what they look like. Finally, the comment section, the last bubble, and then we'll be done. It does tell you a little bit about the rock, and it might actually help you. It might not. So we will get familiar with this reference table, practicing it a lot. I did not give you homework. I feel like you had a lot of homework this week. Enjoy your weekend. We'll pick back up with sedimentary and metamorphic rocks next week. When you're done, go ahead and pack up.